If you're running Lambda functions in a VPC and wondering why your cold starts went from 200 milliseconds to 10 seconds, you're about to learn exactly why that happens and the architecture change AWS made that fixes it automatically.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm really excited about this one because I've been struggling with VPC Lambda performance myself.
Great to have you here. Today we're diving deep into Hyperplane ENIs, which is honestly one of the most misunderstood pieces of Lambda architecture, and understanding it will change how you design your serverless applications.
Okay, so I've been deploying Lambda functions into VPCs because I need to access my RDS databases and Elasticache clusters, but my cold starts are brutal. What's actually happening under the hood?
So here's the thing. Before 2019, every time Lambda needed to spin up a new execution environment in your VPC, it had to create a dedicated Elastic Network interface. Think of it like this. Imagine every time a new employee started at a company, they had to build their own dedicated parking spot from scratch, complete with paving, painting lines, and installing a meter. That took time, sometimes 10 to 15 seconds just for the ENI creation.
That's insane. So every cold start meant waiting for network infrastructure to be provisioned?
Exactly. And it got worse. Each ENI consumed an IP address from your subnet. If you had a /24 subnet with 251 usable IPs and suddenly 300 Lambda invocations hit simultaneously, you'd run out of IPs and functions would fail with any capacity errors. I've seen production systems go down because of this exact scenario.
Wait, so the old architecture was basically one ENI per execution environment?
Correct. Now here's where Hyperplane comes in. AWS introduced Hyperplane, which is the same technology that powers NAT Gateway, Network Load Balancer, and Private Link. Instead of creating individual ENIs per execution environment, Lambda now creates shared Hyperplane ENIs at the VPC to Lambda service level. Going back to our parking analogy, it's like building one large parking garage that all employees share, with a high-speed elevator system connecting to each floor.
So the ENI is shared across multiple execution environments?
Yes, but let me be precise here because the analogy can be misleading. The Hyperplane ENI sits in your VPC and acts as a network tunnel endpoint. Your Lambda execution environments, which actually run in AWS-managed VPCs, connect through this tunnel using NAT. The ENI itself uses AWS's internal networking fabric to multiplex a large number of connections. AWS manages the capacity dynamically, so each Hyperplane ENI can support many concurrent executions, though AWS doesn't publicly disclose the exact limits.
Okay, so when I configure my Lambda with a VPC, what actually gets created?
When you first deploy or update a Lambda function with VPC configuration, Lambda creates Hyperplane ENIs in each subnet you specify. This happens asynchronously and typically completes within a few minutes, though timing can vary. But here's the key. These ENIs are reused across all functions in that account that share the same subnet and security group combination. The ENI creation is a one-time cost, not per invocation.
So my cold starts should be faster now?
Dramatically faster. With Hyperplane, VPC cold starts drop from 10 plus seconds to typically under 1 second, often 200 to 500 milliseconds. The execution environment just needs to establish a connection through the existing Hyperplane ENI rather than provisioning new network infrastructure. When AWS announced this improvement at reInvent 2019, they highlighted the dramatic reduction from around 10 seconds down to sub-second latency.
What about the IP address exhaustion problem you mentioned?
This is where it gets really good. Because Hyperplane ENIs are shared, you need far fewer of them. AWS automatically manages how many ENIs are provisioned based on your concurrent execution needs. In practice, most workloads need far fewer ENIs than before. I had a client running thousands of concurrent Lambda executions that previously would have needed an IP address per execution. After Hyperplane, they saw a dramatic reduction in ENI usage, though the exact number AWS provisions is managed automatically and varies based on demand.
Are there any gotchas I should watch out for?
Two big ones. First, the initial ENI creation still takes time. If you deploy a new function and immediately invoke it, that first invocation might time out waiting for ENI provisioning. Use provisioned concurrency or pre-warm your functions after VPC configuration changes. Second, security groups matter more than ever. If you have 50 Lambda functions each with unique security groups, you're creating separate Hyperplane ENIs per subnet for each unique combination. Consolidate security groups where possible. I recommend creating a dedicated Lambda security group that allows outbound to your database security group on port 3306 or 5432, rather than per-function security groups.
So to recap, Hyperplane ENIs are shared network tunnels that replace the old one ENI per execution model. They're created per subnet and security group combination. AWS manages their capacity automatically, and they reduced cold starts from 10 plus seconds to under 1 second. The optimization strategy is to minimize unique security group combinations and use provisioned concurrency for latency-sensitive workloads.
Perfect summary. One final pro tip: in the Lambda console under Configuration, then VPC, you can see your VPC configuration status. Keep in mind that functions can still be invoked while ENIs are being provisioned, but you might experience longer cold starts during that period. To track any provisioning in your C/CD pipelines, use CloudTrail to monitor Create Network Interface API calls where the principal is lambda.amazons.com, or check the VPC configuration status via the Lambda API.
This explains so much about the weird latency spikes I was seeing. I'm going to audit my security group configurations today.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone who's deploying Lambda functions and VPCs.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.